Notes for simplifying radicals. Well, we have a problem, the cube root of 375, and we want to simplify this. Well, there's no cube root of 375, so what we have to do is we have to factor 375 and see if we can find factors where one of those factors will be a cube root. So of 375, well, we determined that 125 times 3 is factors of 375, and 125 is indeed a perfect cube. So 5 times 5 times 5 is what gives us the 125. So the cube root of 125 is 5. We cannot find a cube of 3, a cube root of 3. So that stays inside of the radical, and our result is 5 cube root of 3. In our next example, we want to simplify the cube root of negative 640. Well, given that we have an odd power, when we have odd powers, it is okay to have a negative inside of our radicand. And given that we can do that, our negative is going to be a part of our result. So we're going to have a negative result. So we take 640, and since we can't find a perfect root of 640, a perfect third root or a perfect cube of 640, then we will factor it out. So we get 64 times 10. And by factoring it out, we find that 4 times 4 times 4 is 64. So 64 is a perfect cube. We can't find a cube root of 10, so that stays inside of the radical. And our final result with the negative brought down is negative 4 cube root of 10. In our next example, we have a fourth root of 48, a to the third, b to the eighth, c to the 21st. Starting with, what we can do is we can break down each one of the factors into their own. So we have the fourth root of 48 as our first. And again, we can't find a fourth root of 48, so we try to find factors where at least one of those factors is a perfect fourth root. And we find that 16 times 3, where 16 is a perfect fourth root. So 2 times 2 times 2 times 2 is gives us the 16. So the fourth root of 16 is 2. We can't find a fourth root of 3, so we keep that inside of the radical. And same thing with fourth root of a to the third power. Well, as long as your power inside of your radicand is smaller than the index or the root out here, then we can't do anything with it, and that stays the same. So we bring that along with the 3 back inside of the radical. The 2 comes out. We have b to the eighth. Well, using the rules of rational rational exponents here, we can write this as b8 to the b over 8, b 8 fourths, or in other words, whatever root you have out here, that becomes your denominator. So b to the second is what that becomes. In the next part, we have c to the 21st originally, but 4 doesn't divide evenly into 21, so we can use the rules of exponents to break that up to c to the 20th times c to the first power. Now remember the rules where if we have the same base, we can add the exponents. So that gives us back the 21st power. Now see 20 divided by the 4 power is how we can simplify this. Can't do anything with the c to the first power, and so we just keep that inside of the radical. So we simplify c to the 20th divided by the 4th power. That becomes c to the 5th power. Now we can put everything together. So already inside of our radical we have 3a to the 3rd power. So this c is also going to have to go inside of the same radical, and we do that. 3a to the 3rd power c. On the outside is going to be our 2b squared and c to the 5th power. So our final result, 2b squared c to the 5th power, 4th root of 3 8 cubed c.